aggravating.
When the guys at Thermo were working on their plastic magazine in 2016, I remember, they kept having to fudge it and make it stronger here and there, and they spent hundreds of thousands of dollars on molds. I mean, very quickly.
So this is, I think, even more critical because it's got a whole, 50,000 psi, and it's. But the big change over time and cost is what really costs you. And there's so many possibilities with plastics and all that.
You can just say goodbye.
Are you leaving?
Wave a white handkerchief.
I didn't even have a mic. We'll see you Monday probably.
Plastic ammunition, it works. You have to have it the right size to fit the gun. If it's too loose, it can crack. If it's too tight, it will swell and won't go in. So it's a little more than meets the eye. The other thing that I was telling you about that was the fact that this plastic case acts as a nice cushion to prevent good primer indent.
So it actually is sort of like a shock absorber.
Mm-hmm. So the normal inch-pounds of energy that you would need with certain velocities and all, in a normal case in metal it isn't the same in the plastic case. You have to go considerably higher energies and velocity levels.
Okay, now, meanwhile, you said when you were developing your LMG that you did it in sort of a skunkworks. I'll get that out.
Mm-hmm.
Where is your skunkworks?
Well, presently it's in Florida, and it's just a one-man shop, possibly two people sometimes, and that's it. And rather basic machinery. And when we get into a part that I've designed around sophisticated cams or something that are 2-3D type cam movements, I occasionally have to send the parts up here where we have this type of machine to be made. But basically, it's in small arms, we keep it down to just a 2 or 3 man operation, keeps the paperwork down and makes things run faster and smoother. When you go into a program that's in response to an RFP for a development program for the government, they frown on that type of an operation, and so therefore, like on this future rifle program that we're working on here now, that's pretty well precluded as far as skunkworks is concerned. You just can't do it and comply. So that's done in the larger shop and paper mill.
Okay. Where do you do your actual drawing?
At home.
Do you have a drafting table at the house?
I have a regular office set up with drafting table and library and so on. So that's usually, print files and whatever goes, the regular engineering setup. And I find that in this kind of work, it's, at least for me, pretty essential to be by myself and do it. I have a very difficult time working like in this environment here with all the engineering and people around and interruptions and running down people problems or whatever. I guess you just lose your concentration or whatever, so I can do it a lot easier by myself and prefer to do it that way. And this is particularly adapted to the small arms things where you don't need large design teams and all. But generally, even in some of the larger caliber guns, I like to do the initial layouts and the initial ideas and everything on my own.
With the Advanced Combat Rifle Program, of which the Advanced Individual Weapon System is, I guess, the first weapon to be developed, and they may ultimately create a weapons family. It's not clearly defined yet. How does the paperwork for this, in terms of volume, compare with what you would generate with yourself and maybe 2 machinists working on the LMG?
Well, the proposal effort alone is generated on this program, just to respond to get the contract, was probably 10 times more paperwork than I would ever generate in 5 years, I think. on my own. And also the formality of the prints and all, and what the print procedures are to go through to comply with regulations. For instance, we even have to use a particular format. You can't do it on the backs of envelopes and toilet paper or whatever napkins that happen to be around. It all has to be very formalized to meet the terms of the contract. It means it has to be checked and double checked. It has to go through quite a few stages. And same way with the materials that go into the weapon. Even though it's a prototype, it has to be all certified materials, be able to trace origins back, to the beginning of the material. So it makes it considerably more expensive and a lot more people involved to do the job.
Also must make it eat up more time.
Considerably, yes.
I mean, just in terms of getting the documentation.
Mm-hmm. For instance, in a part for this prototype weapon, if we wanted to send a part out for heat treat or for plating, it has to go to a vendor that's been approved by the U.S. government. If we had a good vendor right across the street, but he did everything we needed, but didn't have these formalities and approvals, it'd be illegal to send it to him.
And he's going to charge you more than somebody who's not certified.
Oh, yes. Yes, absolutely.
How did you, in terms of the ammunition concept for the AIWS, how did you get to the telescope tubular round? Where did that come from?
Well, this was an idea I had several years ago, and I was working on 20 millimeter guns, and I took a 20 millimeter projectile and machined up some cases out of steel, and we had the man barrels and so forth here, so I tried to make a telescope round that actually fired with the same velocities and same characteristics as the brass case round. Tried it out, the scheme out, and it worked pretty well. And then later on, we got involved in some other programs with telescoped ammunition, such as the 75 millimeter and the 25 millimeter systems and so forth. And those were all based, though, mainly on higher performance rounds of ammunition. In other words, to consolidated charges and so forth. And in working with telescoped ammunition, I've noticed that there was quite an opportunity there for new gun designs, because the gun mechanisms could be considerably different than they were in the past, such as the fact that you didn't have to extract a round of ammunition. You could actually push it through and eliminate an extraction process, make the gun fire faster. You could eliminate some parts, and it was a matter, of adapting new design concepts to new ammunition concepts. Don't try to use them the same way as they were before, but different ways. And we also found that due to the fact that there were a lot of opportunities on new designs, there weren't any standard telescope rounds of ammunition available, and those that are available, or not too available, but are around, were very, very expensive. And I always felt there was a need, if we were going to develop all these new gun systems, that we had to have a round that we could get at any time and be able to test a new design. So that was the whole idea of coming up with a 50 caliber that I have here, telescoped ammunition. I picked 50 because it's kind of an in-between caliber that I felt fairly comfortable scaling up or down from. And I didn't want to improve the ballistics any. And the main reason was that if you improve the ballistics, it meant that you then lost the comparative value of the rounds. In other words, we could always compare this with a round with exactly the same ballistics in the brass case. So we shot the same bullet, which is available on the market, the same propellant, the same primer. All we were doing was changing the configuration and the case with the plastics. But we could use this round and put it right up alongside of a 50 caliber round and you could say, here's the direct comparison of what you can go by not improving the ballistics, but just getting the same characteristics. You can save approximately 40% of the weight of the ammunition. And then we had a gun that went with this that we could say, here it is against the standard 50 caliber machine gun. Now, if we decided to go up in the ballistics and say that we were going to run this up to 5,000 feet a second instead of 3,000, the cartridge case would get much larger, the gun system would get larger, and you would lose track. You'd be this apples and oranges comparison. So I was criticized quite a bit by saying, well, why did you just do it, you know, with standard ballistics? Well, the reason was so that future prospects or whatever could compare it directly. And then this was intended mainly as a test vehicle anyway. So we started developing this ammunition mainly for that, to have something to shoot that was cheap. So out of that came the 5mm round, which is this round, which is almost identical in design to the 50 caliber, scaling it down, and using some of the basic ideas in mechanism on the weapon that we developed in some of these calibers here, meaning, for instance, that we use the push-through ejection system and so forth, and we were able to save a considerable amount of weight in the system also, which is very, very important in an infantry weapon.
Would you save cost ultimately as well, do you think?
Yes, well, in the medium caliber cartridges, such as the 50 caliber or small arms, and maybe even up to 20mm, the brass cartridge case is the most expensive part of the round of ammunition, and it requires considerable know-how to manufacture and specialized machinery. And by going to the plastics, this case could be, once it's developed and the materials picked and all that, could be put into any injection molding machine, and there are literally millions of in the United States, and anybody could build it. So it would be extremely competitive cost-wise. In an emergency, it would be available any place.
So somebody making knobs or buttons could turn around and make ammunition.
That's right.
Could you hold that 25mm case up and show what a telescope round actually looks like?
Okay. This is basically the way most of them are designed. The telescoping means that you've actually pushed the projectile down inside of the cartridge case, and that the cartridge case then ends up as a cylinder rather than being tapered. We should have some other cartridges such as this. You don't have the typical bottleneck and all, and specialized forming operations and everything to make the cartridge case. So it also means when you get a right cylinder that you can handle this ammunition in mechanisms completely different. This is tapered in all directions. This is not. It also means that it can be handled like, in some respects, like in a canning factory or whatever, running tin cans is more or less a right cylinder and can be handled the same way as that. So the sealing characteristics are such that in a telescope case, it seals at both ends so that you can have a chamber detached from the barrel, and the cartridge case can seal at the front end and at the back end. The normal case only seals at the rear end because it goes has to be shoved into a barrel and extracted from the chamber. But basically, the way these things work, and some of these have subtle differences in the way the cartridge actually works. This one is rather typical of the larger sizes, where the initiation of the primer sets off a small charge in the center here, and this small charge in the center actually ejects the round from the cartridge case and pushes it up into the neck or the beginning of the barrel. And actually what happens, it takes this round and momentarily in the rifle or in the weapon makes it look like this round that's already, when it's chambered, has the bullet in there. It does that with this ejection charge. Then the main charge is uncovered to the flash of this one, and that starts this one burning, and then it works like a conventional round. And this is rather typical. We use a little different approach in the small caliber, 50 caliber in this, where we don't use this starting charge, but actually just start this charge burning right away and just push the thing right out of the end of the cartridge case. And this has the advantage that we can use what we call a consolidated charge or a solid propellant. And this not so easy to do in this case, but it's easy to do in this one.
Now, in the 50 caliber and in the 5.56, or a 5 millimeter rather, you have a cap that you fire the bullet through. Is that right?
Yeah, there's a sealing cap here, and there's also one on these too. But there's a sealing cap right here, which is actually formed by this enclosure, and that's a very thin cap that's just it's an environmental seal. It's hard to see on this one, and during firing, that cap is just blown off into the barrel and down the barrel ahead of the projectile. And it usually doesn't affect the ballistics or anything like that at all. But that's just to get a sealed unit here, similar to what you have here. You have an environmental seal around there. But you can see without that cap, there'd be ways of getting water and whatever down inside.
Using your the drawing up there on the board, could you show us how you put that ammunition through the weapon? I think it'll allow you to do that.
Well, this is not too good a drawing to show that. The ammunition is actually stored in a drum with a kind of a plastic tape in this case, or a link. And part of this mechanism that reciprocates, this is your gas system, your gas piston, and this is in place of a bolt. This thing doesn't really have a bolt. This reciprocating rod here, actually this little lip strips off a round out of the magazine and pushes it into this chamber. This chamber's got kind of a horseshoe on it. It actually acts as guides that moves up and down the receiver. And then when the round is pushed into the chamber, the previously fired round is actually shoved out ahead of it and is ejected out forward into the side of the weapon. This chamber then is released and slips vertically up into the receiver where it aligns with the barrel, and it's fired. And then when this mechanism, the slide, moves back, these cam or angular cuts here push down on this little horseshoe shape or fork thing and forces the chamber back down into its loading position again. And then the rammer picks up the next round, shoves it through, and the whole process repeats.
Can you get a fairly high rate of fire that way?
You can get a fairly high rate, yes. This type of mechanism is not what we call our real high rate approach. That's a completely different mechanism we use on some of the larger caliber, like the 25 millimeter guns and all. But this would can fire at a fairly high rate. In fact, in this particular rifle application, one of our problems on the prototype was the rate's too high, and we're in the second system. We're actually linking the stroke and doing some things to slow the system down some. But that's basically how it works. This system also has a unique characteristic that the chamber, being it's a tubular chamber, and it is always down until the moment of firing, is never up close to the hot barrel. The chamber is always insulated by the plastic cartridge case, so it never gets hot during firing. And you can fire a long burst and it's always cool. And the only time that you can get the ammunition hot at all is the moment you pull the trigger. A spring drives this thing up to start the firing sequence, drives it up in line with the barrel, and you could get some heat transfer from the end of the barrel to the chamber, but that's only an instant, so you don't really get much. So we don't have any cook-off problems with this thing. It's kind of unique in that way, and great help, from the standpoint of safety. The fortunate thing is that the one I'm talking about isn't the Air Force, but the Air Force system was derived from it, so you got to be careful.
I know where you. What does this drawing represent in terms of the maturity of a design? I mean, obviously you've gone beyond sketches and you've got, the better part of early prototype, but how far along are you in the process when you have a drawing like this on the board?
Well, this actually represents the first prototype. And this is the type of drawing that you have to do in order to file your reports with Uncle Sam and so forth. So if this was a job that could be done in Florida, you wouldn't see any drawings like this at this stage. You'd see them at a stage after you start manufacturing many, many weapons, but it really isn't necessary, except it's under normal circumstances, but it's necessary in order to comply, I should say, with reporting.
Okay. Now, what is the sort of using philosophy behind your AIWS, and how does that differ from what other people might be approaching in the ACR program?
Well, this is considerably different. I guess it's a unique approach. It's my idea, I think, of what a future rifle probably should be because of past experience on how small arms are really used. I've always felt that the user, the Army and so forth, have never been very realistic in their proclaimed use of small arms. In other words, they train people to shoot at long-range targets. They train them to line up sights carefully and hold their breath and squeeze the trigger. And that's beautiful when you're shooting at targets. In combat, at least the experience that I've had and seen in it, and viewed many, many, many films on the thing and read a lot of reports from people that I had some respect for, have always led me to believe that the target disposition and the way that the weapons are used are at extremely close ranges. They have almost zero effect at long ranges. And so by using that concept, well, first of all, what the Army was trying to do with the ACR program was to some way increase the hit probability in combat stress situations. They even recognized there was a difference between shooting at white targets, in a nice summer day, than shooting at the enemy that was trying to kill you, and the pucker factor and all that. They realized that there was something wrong in the fact that you could shoot literally hundreds of thousands of rounds of small arms ammunition to account for one enemy casualty. That number, by the way, hasn't changed much since they've been keeping score, some scorekeeping in World War I, II, and Korea and everything. And the numbers run, I think, in the neighborhood of 200,000 or 300,000 per casualty. So what they were trying to do was to, in some way, improve the hit probability by design of a weapon system. And they were leaving it, in this particular case, quite a bit of latitude in how you would do that, because all efforts to date have not changed much. There's very little difference between one rifle and another as far as hit probability in combat. And they were saying that we would like to double the hit probability of the M16 rifle in combat situations. And so I looked at this thing and I decided to take quite a bit of latitude and try to come up with a weapon that could be fired at targets that I thought would be true combat targets, which means probably nothing within or beyond about 300 meters. Experience has shown that in combat situations you very rarely ever see the enemy beyond 300 meters. You very rarely ever hit them beyond 300 meters. In fact, historically is shown that most rifle hits are well within 100 meters and the rest of the shots are wasted. The other thing is that if you look where ammunition is consumed, it's consumed almost 99% at targets other than enemy targets. It's shot at things or places where the enemy might be or whatever. It's used more for keeping heads down and denying maneuverability to the enemy than it is killing them, but just scaring them or holding them in place. So the assumption the Army had made for many, many years was the fact that due to the pucker factor, or as the stress of combat, caused a soldier, when he aimed, to aim very haphazardly, and his aiming errors were very great compared to when he went on the rifle range and shot at a normal target. Well, therefore wanted a rifle that would shoot in effect like a shotgun, that would make up for aiming errors and spread a group of shots around to in a certain scientifically derived pattern or size that would therefore increase his hit probability. The contention I had, and it's yet to be proven, was the fact that in that system you have to assume he's going to aim. Well, if you look at all the footage you want to look at in combat films, and there was a lot of it in Vietnam and all, you never saw anybody aim. They would just point their rifle in the general direction where they thought the enemy was, and they would let go. And actually there was a lot of combat films that I viewed through World War II and Korea that showed exactly the same thing. The best you could hope for was a man would hold the weapon up and look over the top of the weapon and fire. And there was a lot of speculation on why they don't aim, and there were a lot of studies made on it. And I've always felt one of the reasons is that in the moment of combat where you're being shot at, you want all your senses working at 100%, your hearing and feel and your eyesight especially. And most people are not prone to look through little tiny holes of sights and restricting their view in any way when they're trying to keep being killed. And it takes a tremendously disciplined person under those conditions to really use sights. And generally when sights are used, they're used where the shooter has the advantage, for instance lying in ambush waiting for some poor soul to come down a trail or something, where he can always get the first shot off or two in comparative safety. But when the bullets start flying both directions, he's very reluctant to restrict his vision. And I always felt if there was a window or something big enough that he could see through, he may use his sights. One idea, of course, if you're looking in the future, would be to have a weapon where the sights could be projected on a visor or something and he couldn't ignore them. In other words, or they were literally tattooed on his eyeball, so that wherever he looked he'd have an idea where the weapon was being pointed and he couldn't ignore it. That might increase the effectiveness quite a bit. Another way of doing this, and what we've chosen in the ACR approach, is to use the bullets as the sighting system, such as tracers. So in this system, what we're proposing is that if you can see the target, you start immediately firing from whatever position, and we're making the assumption he's not going to use the sight, and just literally walk the tracer in towards the target, because he's going to have his eye on the target, and all he has to do then is match up where the tracers are going, generally where the target is. The other thing you have to look out for is the targets are extremely ill-defined. Every country in the world now uses camouflage uniforms. They're difficult to see at even 50 meters away, which is going to tend to drive the range down. When they used to have red coats and all, it made it quite a bit easier to shoot at several hundred meters, but they don't do that anymore. They found out that wasn't very productive. So the other consideration is that the targets are not only ill-defined, but they're very fleeting, and you can only see camouflage targets as a rule when they move against any background. It's very difficult to see a man-type target in combat unless you associate it with some movement. Anybody that's trying to stay alive won't get up in a skyline or anything like that where he can be contrasted. So it's driving the ranges down. It's also, the shorter the ranges, it seems to be the exposure times go down. People don't linger around at 50 meters away where they can be shot very easily. They tend to be exposed only a second or two, which also leads me to believe that it's going to make the sighting more difficult. So what we're trying to do by using the tracer fire control system, we're really trying to be able to get on targets faster. We found by training people, as soon as they see a target move, to start to fire from the hip. And just literally then you have rounds on the way just in the general direction, and then move the stream of tracers into the target. And it actually works better than trying to shoulder it up and halfway line up and then start to fire, because that all takes a second or so. We're talking about target exposures on an average of 2 and 3, 5 seconds is a long time. And training in the past by the military have always given people 5 and 10 and 15 seconds to fire a lot of times. And that's not real. It's not realistic. So we're trying to solve the problem by using what we call the closed-loop fire control system. In other words, the tracer is the cue that the man sees with his eye, and through that evaluation closes the loop and tends to move the weapon in the right direction until he hits it. To my knowledge, no one has really tried that before. And I think that it really is something, it may not be the answer, but maybe it'll be a clue, and we ought to try it out. We've done some firing here, and unfortunately, this program is so new, we haven't got what we call conclusive answers yet. It's still to be determined whether this thing is really going to be that much more effective or not. And this also brings up the fact that in order to prove whether this really is effective or not, the combat ranges, test ranges, are going to have to be extremely realistic. You can't take a system like this out over next door to Camp Perry and shoot it at white targets out there on a known distance range. It's got to be done extremely realistic. So that's kind of the theory of this system. The other is to use an ammunition that's light enough that allows you to shoot more without a weight penalty, because we know we're going to fire more. But the rules of engagement at the time was the number of hits per engagement or trigger pull, and didn't say anything about maybe you have to fire twice as much to do it. So what we've done here is try to unburden that part of the problem by making the ammunition extremely light, so we can actually fire more and but get higher number of hits per engagement. You see targets so rarely anyway that I don't think that's a big penalty. The other thing is the bullet is designed to have a certain amount of armor-piercing capability, and it more than meets the need of the range requirements as we visualize them. I personally believe that the Army's, I think due to history or whatever and doctrine, have got their range scales all fouled up, that they should be much, much shorter to be realistic. We have weapons today that are, their capabilities exceed the man's capabilities by a factor of 2 or 3. And for that, every time you increase the range, you have to increase the size of the cartridge, the size of the weight of the ammunition, the size of the weapon. And it just doesn't make sense to go out there and carry something around that's got twice the size and weight that it has to be. And I think when it really in this program, if nothing else comes out of it, if they can actually get around to define what the rifleman's world really is where is these targets, how far away are they, how threatening are they, and a lot of other things, how long are they exposed. I think it'd be, actually it's more important than coming up with a different mechanism. This, in order to help out to achieve our, this system that we have a very low impulse round, which means a squirt gun that you're using doesn't recoil much. It's easy for anybody to point. It doesn't push them off the target. We're putting on it an optical sight that the only time that I visualize this sight will be used at very rarely at long ranges when somebody wants to use it as kind of a pseudo sniping rifle. But I believe that in real combat situations, you could almost throw the sight away and it won't make any difference to the efficiency of the rifleman whatsoever.
Good.
That's my theory.
That's good. That would work. That is the AIWS.
This really gets folded?
No, I don't think so. I think it just sort of lay it over. Here, give it to Howard. And then
I'm sorry, Chrissy.
What do you,
who does these type of illustrations?
Well, we had a technical illustrator that actually did all these. He was very good, but he went to American Electric Power. So right now we're illustrators.
can you just get a still of
Illustrator.
this? That's
Yeah,
really a
that's
good
all you need?
solid still. Give me a good-
Yeah, it's,
Are we better? Should we go down and do that?
it might not be a bad idea. It's some kind of problem.
Okay, let's just do that first.
By the time we get down there, set up, figure out what I talked to one of the guys that's kind of manhandling the LNG project.
No, I'm shooting. I'm a videographer, third unit videographer.
That's great. Have you
Yep.
ever done unit work for them before?
Yeah, once before. Kelty couldn't make it, and Bueller's going to be there late. So I guess I'm third on the totem pole.
Lucky day left. Want to be in lots of
Well, I hope so.